Question 22. It's 4 marks. The problem of this question is you don't even know what they want. Let's read it. The question says the total area of the region shown, shaded in the diagram, is X. AB is 11.5, correct to the nearest 0.5 centimeter. BC is 9.2, correct to 2 significant figures. The side of the square is 4.1 centimeters, correct to 2 significant figures. By considering bounds, work out the value of X to a suitable degree of accuracy. Suitable degree of accuracy. Now, students read this question and they don't know what to do. Since they mentioned bounds, just think of finding the upper and the lower bounds of the area, and then let's see how it goes. Now what we will do is we will find the upper bound of the area and the lower bound. To find the upper, the maximum value of the area, we need AB to be the biggest, so the upper bound. We need BC to be the biggest, so we get the very big value, so we'll use the upper. And we need this to be very small, so we'll use the lower. Do you get me? So I'll use the bigger, the upper bound, and the lower bound to make the area to be the upper or the biggest value. I will then, after I do that, I will want also to find the lower bound of the area. So I want this to be the lowest, the lower bound of this, and I will need to find the lower bound of this, and then I will need to find the upper bound here. That gives you the smallest area. So we will use different things. When we use the lower bounds out there, we use the upper bounds inside. Now let's find the values. For AB, they said to the nearest 0.5 centimeters. So the first step is you divide by 2 is 0.25. Now the upper bound for AB is going to be 11.5 plus 0.25, which is 11.75. Now the lower bound is 11.5 minus 0.25, which is 11.25. Now let's go to the other side, which is BC. Let's write it in red. We will also find the upper bound and the lower bound. So let's read. BC is 9.2 to 2 significant figures. 2 significant figures means it's 1, 2. So the place value here is tenth. So it's 0.1. We divide by 2. It's 0.05. Now to find the upper bound, we add the 0.05 to the 9.2. So it's 9.2 plus 0.05, so it's 9.25. And to find the lower, we do 9.2 minus 0.05, so it's 9.15. Finally, the square inside here. They say this length is 1.4. So the square, so 4.1 to 2 significant figures. So 2 significant figures is 1, 2. So this place value is 0.1. So we will also do 0.1 divided by 2, which is 0.05. Now we can either add or subtract to 4.1. To find the upper, we do 4.1 plus 0.05, which is equal to 4.15. And to find the lower is 4.1 minus 0.05, which is 4.05. That's a lot of work, isn't it? It is. But you should do this. Now, let's find the area now. The upper bound of the area, we will use the biggest value here. We'll use the upper bound, and we will use the lower bound. So the area of the rectangle is going to be 11.75 times 9.25 minus the area of the square inside. So we need this to be the smallest. So what I will do is I'll use the lower bound here. So it's going to be 4.05 times 4.05, which is 4.05 squared. Now, to find the lower bound of the area, the lower bound of the area, we will use the lower bound here and the lower bound there and the upper bounds here. So it's going to be 11.25 times 9.15 minus 4.15 equals. That's it. Now, plug this in your calculator. You will get two values. You will get 92 point something and you will get 85 point something. Now let's go back to the question. The question says a suitable degree. Suitable degrees, look at these two numbers, 92 point something and 85 point something. Have you noticed if we round these two to the nearest 10, 92 point something and 85 point something, if we round them to the nearest 10, we got 90. And that should be your answer because they both round up or round down to 90. And that's your 4 marks. This is tricky, not easy, not nice question, but that's how you should do it.